This is an example of a word problem that really proves the point that you have to organize your work in math very carefully, because this problem overall is quite simple, but if you're not paying close attention, if you don't organize your work, it seems a lot more difficult than it is. So when you're approaching any word problem, of course, you have to read carefully. We have these two ships, and we're talking about relationships between their distances, their speeds, how long they've been traveling, and so on. Once you've read the question, especially in this case, and any time in a word problem where you have anything that's even slightly geometric, you want to sketch a diagram or draw a picture, and that's certainly possible in this case. So I'm just going to draw a little line that represents the cruise ship and how it's traveling. So this red line is going to represent the cruise ship, and then in blue, I'm going to draw another line that represents the container ship. So if you read the question, the container ship is trying to catch up to the cruise ship. So sometime later, it's going to start from the same spot, and since it's going faster, eventually, it's going to catch up to where the cruise ship is. Now certainly this is a really crude diagram, but it's going to do the trick when we start doing the algebra for this problem. Now, just like an example that you've seen in class, in these sort of distance, rate, time problems, and lots of other type of word problems as well, you're much more likely to be successful if you organize your work into a nice, neat table. So that's what we'll do, just like you saw in class. So we're going to talk about the cruise ship's information, and we're also going to talk about the container ship's information. And since we're talking about distance, rate, and time, I want to talk about all three of those quantities for each ship. So I'll just form this table with rate, time, and then finally distance. And I'll just emphasize that we know a relationship between distance, rate, and time, and that is distance equals rate multiplied by time. So in this table, I'm going to have 6 spots for all of my information. Okay, so I have to read the question and I have to be very clear on what it is I'm looking for. So let's see. After 3 hours, the container ship finally caught up. Well, that's not asking the question. And then find the cruise ship's average speed. There we go. That's our variable, the cruise ship's speed or the cruise ship's rate. So I'm going to put my variable in this box, which I'll circle in green. You can choose whatever letter you like. Sometimes I fall into the habit of calling all of my variables X. I won't do that this time. I'll call this R for rate. So there we go. I'm looking for the cruise ship's speed. That's the variable R. And now I have to fill in all of these other boxes with the information given in the question. So if we read carefully, it says a container ship left traveling 4 kilometers per hour faster. And it's the 4 kilometers per hour faster that lets us fill in another box. The container ship's rate is R plus 4. Now again, reading carefully, we'd like to fill in these boxes with information about time. So let's see, after 3 hours. Now be careful, you have to know which ship you're talking about here, and it says just after. We're dealing with some information about the container ship. So the container ship traveled for 3 hours when it caught up to the cruise ship. So let's see. Now we need the cruise ship's time. And this is a really common place where you might make a mistake. If you're not reading carefully, you might put 2 in the box for time, and that is incorrect. If you read carefully, the cruise ship started first and the container ship left later on. That means the cruise ship has been traveling for a longer amount of time. How much longer? 1 hour longer. So the cruise ship hasn't been traveling for 2 hours, it's been traveling for 4 hours. At this point, I'm going to let algebra take over just a little bit. Rather than trying to fill in the distance boxes with any kind of new information, I'm going to use the relationship between distance, rate, and time. That is, distance equals rate multiplied by time. So for the cruise ship's difference, I have 4 multiplied by r. In the container ship's distance, I have 3 multiplied by r plus 4. So now I understand at least a little bit of information about the speeds, the times, and the distances for these two ships, and now I actually have to write an equation. And this is where it's important that you have drawn a diagram. If you're just going through the motions and looking at some examples that you might have done in class, or you're working with a friend and you've seen the way that they've done some of the problems, you might make the mistake of maybe adding these distances together and thinking you get something, because some problems are like that. However, if you pay attention to this diagram, you'll see that the cruise ship and the container ship traveled the same distance because the container ship left from the same spot and then caught up. And the words that I just said represent an equation. They traveled the same distances. Their distances are equal. So I can write 4r, the distance that the cruise ship traveled, is equal to the distance that the container ship traveled. And we have a really simple equation to solve. Go ahead and finish it, I suppose. Use the distributive property. Now if you subtract 3r from both sides, we get r equals 12. And what you should really do is write some sort of a little summary or sentence. It doesn't have to be extra lengthy. I'm running out of space. I'm not going to write any English. I am going to write the answer along with the proper units for this word problem. What I should really do, if I had a little bit more space and I wasn't doing this online, is write something like, the cruise ship's average speed was 12 kilometers per hour. Anyway, I wanted you to see another example of word problems like this. Just reading the question, it seems like this might be a really difficult word problem, but once you organize your work and you read carefully and you draw an appropriate diagram, it's really not that bad.